Okay, so it's exam season, and we're going to have a look at some revision on, it's within the topic of forces, 4.5 on your spec, which is always worth checking. Specifically, we'll cover a few of the ideas, but specifically I want to concentrate on how to use this equation, commonly known as the SUVAT equation, or v squared minus u squared equals 2as. So the first thing you need to know, something that you can revise just by rote learning and will be of benefit in the exam, is what do each of the individual terms mean in v squared minus u squared equals 2as. So the v is, as it says here, the final velocity. Final velocity. The u, as it says here, u is the initial. Initial being the beginning. Initially I was apprehensive about physics. Initial velocity. A is acceleration, right? S is displacement. Well, it says distance, but technically it actually is displacement because it is directional displacement. So it's always good to know what these things are measured in. So have a guess. Velocity, meters per. If you said seconds squared, you need to do some revision. Initial velocity is also in meters per second. Acceleration is meters per second squared, and displacement is meters. Right, so let's have a look at just normal usage of this. Right, I initially was tempted to suggest a student should find out what they're missing. So if you need to find S, so here is an example of something you might have done in class. Find the missing values and show all your working. So you might have to find this missing value for this missing value here for A. Okay. Now, so if you were trying to find that, you would have initial velocity, final velocity, and the acceleration, and you'd need to find the distance travelled. So essentially you'd have this term in the equation, this term in the equation. Obviously you've got the 2, you'd have the acceleration, but you would have to find this, right? So I might have suggested that you rearrange the equation at this point, but I think we're going to try a different tack today to make things a bit easier. So along with that different tact is I'm just going to sub all the numbers I know straight into the equation as is, and then calculate from there. So v in this case is 20, so I'm literally going to sub straight into this equation. V squared minus u squared equals 2as. So 20 squared minus 10 squared, because that's the final velocity, is equal to 2 times the acceleration, which was 2, times s, which is what I don't know. So I've still got my unknown value in there. Maybe you even want to replace the unknown. If it's familiar with you from mathematics, the unknown is the x thing you're looking for, right? Okay. So assuming we've got that far, let's see if we can work this out. 20 times 20 is 400. I'll check anyway because I'm concentrating on too many things at the same time. So 400 minus 10 squared, that's 100. Should be equal to 2 times 2, that's 4x. Now I can tidy this up and simplify. So 300 is equal to 4x. So I think most students would find this relatively straightforward to rearrange from here. So I've got, it's £300 buys me 4 chocolate bars. How much is each chocolate bar? I have to divide the 300 by 4. 300 divided by 4. So 300 divided by 4 tells me 75 what? Pounds if it was chocolate bars, but it's not chocolate bars, is it? So I was working out S, displacement, so it's 75 meters. So if you had a vehicle or something starting out at initial velocity of 10 meters per second and finishing at 20 meters per second, and it was accelerating at 2 meters per second squared, then the displacement, the distance that object would have travelled, would have been 75 meters. Let's try this same technique for the next question. So with the next thing missing, just delete that out. Okay. So let's see if we can find the missing value u. By the way, this is also a pretty standard and sensible way of approaching these problems. So let's start by just writing out all the terms we need. V, U, actually I'll do it how I normally do it. S, U, V, A, T, right? You can just type out, collate all the things you might know in the question. So in this next line I'm trying to work out, right, so this is saying we know the displacement is 75. We don't know the initial velocity. That's the missing value. We do know the final velocity is 10, and we know that the acceleration is -2. Okay. Notice there's a minus in there because we also don't know the time, because acceleration, like velocity, is a vector value. It has both direction and magnitude. My gosh, the snow's coming down heavy. Right. It has both direction and magnitude. So if the acceleration is in the opposite direction of your velocity and your velocity is positive, then the acceleration would be deceleration, right? Because it's doing the opposite of what your initial velocity is. And to signify that, we put it as negative. I'll put the units on all these as well because it's a good habit. So we've got displacement in meters, initial velocity will also be in meters per second, final velocity meters per second, acceleration meters per second squared. Negative acceleration is exactly the same as deceleration, and time would be in seconds, although we're not really concerned with time because this equation doesn't even have it. Right, now let's sub all the numbers into the equation. V squared minus u squared equals 2as v squared. So the final velocity here is 10, so 10 squared minus initial velocity, which is u squared, which actually I don't know. So again, if this is how you're more comfortable thinking about it, that's the x, that's the thing that you're solving for, right? So 2, yes, I know it's 2 because that's already in the equation. Acceleration times -2 times the displacement, which is 75. So all these values have just come straight out of this table, or they'd have come straight out of the question you're solving. Right, 10 squared is 100 minus x squared, the thing I'm looking for. 2 times -2 is -4 times 75. Right, -4 times 75 is going to be -300. So let's just keep going. 100 minus x squared equals -300. Just to make sure I'm not being thick. 4 minus 4 minus 4 times 75. Yes, it's -300. Shouldn't doubt myself. Now it's a bit messy, isn't it? So x squared is being subtracted here. So I think I'm going to add it, right, to the other side. So that will shift the x squared over to here. So I'll do that now. 100 will be equal to -300 plus x squared. Okay, so that's got the x squared onto one side. Now I've got -300. What shall I do with that? If I add 300 to both sides of the equation, so I get 400 on this side, and -300 plus 300 will be equal to 0 plus x squared. Okay, so now I've got x squared equals 400. And to get rid of the square, I'll do the opposite of that, which is root both sides. So if I root this side and root this side, this and this cancel, and I'll just be left with x equals root 400. I think I remember from the previous question that 20 times 20 was equal to 400, so the square root of 400 is 20. 20 what though? Not 20 chocolate bars. So it's initial velocity I was looking for, which is in meters per second. So this thing's initial velocity must have been 20 meters per second. Okay, let's do one more. Let's just do the next two, C and D. Okay, so again, let's start with, I'm doing this line now. Let's see what I've got. sub in. In fact, why don't you try as well, follow along with the Wafi. So stick in your numbers. We've got v squared minus u squared equals 2as. Okay, so have a crack. What's v squared? What's v? V's the value I don't have. This is the unknown. Again, if you really want to, replace it with x, if that helps you think about it. U, in this case, is 200, so it's going to be 200 squared, will be equal to 2, the number I'm already given, times the acceleration. In this case, it's telling me the acceleration is 7.3. 7.3 times the distance, 633. Whoops. 633. Okay. So x squared minus 200 squared will be equal to 2 times 7.3 times 633. Right. All of that can just be crunched out and bashed into the calculator. So off we go. 2 times 7.3 times 633 equals a big number, 9241.8. 200 squared, that's going to be about 4,000, I suppose. 40,000 maybe. So 200 times 200 is 40,000. So minus 40, 1, 2, 3, and x squared, right? So I've got to that line. Now I need to get x squared on its own. Easiest thing to do is to add 40,000 to both sides of the equation, which will cancel the 40,000 off this side and add 40,000 to this side. So it will be x squared is equal to 9241.8 plus 40, 3 noughts. Okay. So plus 92. Back on the calculator, eh? See? You need them in your exams. You need to know which one you're using as well. 40 plus 92.9241.8. So we get 49,241.8. That's x squared. And again, we're squaring on one side, so we can take the square root of both sides, which cancels on this side and leaves us with the square root of that. So x is equal to the square root of all that business. So if I take the square root of my answer, square root shift, well, it's not shift on this calculator, square root answer is 221, whoops, 221.9. I'm going to round that to 222. Now, what was it I was finding again? C. So I was finding the velocity. So that will be meters per second. So this should be 222 meters per second. So again, another one solved. If you had paused the video and that's the answer you got, you've done very well. Right, we'll do one last one. So we've tried all the different rearrangements, and then we'll look at our exam question and see if we can apply what we've learnt in that situation. So let's have a look. In this final line, we're being asked for find the missing value that is represented by d. We're being asked for the acceleration. So let me just clear some space here. Okay. Could have done this faster. Right, let's have a look. So again, I could write out SUVAT. What do I have? Do I have S? Yes, it's 300 meters. Do I have U? Yes, I do. The initial velocity is 15 meters per second. Do I have the final velocity? Yes, I do. It's 45 meters per second. So I can see here that we started at 15 meters per second, we finished at 45 meters per second, so the acceleration should be positive. Okay, so I'll be looking for the acceleration, but I do know that it's got to be positive. So if my answer comes out negative, I must have made a mistake somewhere. So acceleration is the thing I don't have. I don't also have the time, but that's okay. Like I said, as a convention, in physics, SUVAT represents nearly all the things you'll be worrying about in a motion type problem, and if you go on to do A-level, sometimes you'll be asked about the time, or certainly in the GCSE as well, if you're looking for just standard acceleration, it's change of velocity over time. So this just helps you collate all the different things that you might know about the question, and then you can look at the equations you know and work out which one will work. So I know which one's going to work because we know they're all v squared minus u squared equals 2as questions. So v squared minus u squared equals 2as. Sub in what I know. V is 45 squared minus u, which is 15 squared. 2 times a is the thing I don't know. So if you really want, I'll replace it with an x. Times s, which is 300. Okay, so 45 squared. Get your calculators. You need them. 45 squared is 2025 minus 15 squared. I can't do that in my head. 15 squared is 225. 225 should be equal to. I can still simplify this, so it's going to be 2 times x times 300. Order of multiplication doesn't matter. That's 600x. Right, so 2025 minus 225 should be 1800, but I'm going to check anyway. Yes, so 1800 equals 600x. So, like the first question we did, 600 lots of x equals £1,800 if you want to think about it like that. You know, £1,800 bought me this many x's, x boxes, whatever you want to think about. So if I want to find out the price of just one, or I want to find out the value of just one, I can divide both sides by 600. 1800 divided by 600 will equal x. That will be 3. 1800 divided by 600 is equal to 3. 3 what? 3 meters per second squared, because it's acceleration we're looking for. Notice I double underline my answer on that one. It's because also a good habit to allow the examiner to know what your final answer is. Right, so we've done a couple of we've played with the rearrangements and stuff. Now let's have a look at an exam question. Okay, so I would suggest that you pause the video and have a read through. It's good revision. Have a go at the question first. So this is part 1 of the question. Pause and have a read. Maybe try it. Have a go at part B. Have a go at part C. They give you the equation in this one. D, E, F, and G. Okay, so I would definitely recommend, you won't get better at physics without practice. I would definitely recommend, don't just sit there passively watching me solve these problems. You have to have a go at it. You have to make mistakes. You have to find out what you understand and what you don't understand. Just watching me solve problems for you is not going to help you understand. But hopefully you've been honest with yourself and you've had a go. Let's see. I actually haven't had a go at this question yet, and I haven't even seen the mark scheme, so hopefully I'll get it right, and I'll check, and if I make mistakes, I'll let you know. Right, the figure below shows the horizontal forces acting on a car. Which one of the statements describes the motion of the car? Let's have a look. Right, forces are balanced. Newton's first law states that when forces are balanced, or there's no resultant force, motion remains constant, motion being both magnitude and direction of velocity. So velocity remains constant. First law. So it will be, you don't know that it's stationary. It could be stationary. Velocity could be 0, but velocity could be any other value as well, but constant. So it will have constant speed. It will be speeding up. It will have constant speed is the closest to the right answer, I think. What you can definitely say is if those are the forces acting on the car, you'd also have weight acting down and the force of the ground pushing back up again, which we're assuming is equal. I'm assuming the car's not floating up into the sky or accelerating up or accelerating down. If these are the pertinent forces, the ones we're interested in, they're equal in magnitude, they cancel out, there's no resultant force, therefore there's no acceleration, and velocity remains constant. Next bit, B. During part of the journey, the car is driven at a constant speed for 5 minutes. Which equation links distance travelled with speed and time? So, speed equals distance divided by time. Velocity equals displacement divided by time. Speed is without direction. Velocity is with direction. Okay? Pretty much most of the time you treat them as though they're the same thing. So if I want distance travelled from either of these equations, I need to rearrange for distance. So some people really struggle with algebra. I might go ahead and multiply both sides by time, so I can cancel the time out here. Or you could try and put this into a triangle, and the triangle works like this. Whatever's on top goes here, and whatever else is left over is down here. Anything in the bottom of the triangle is timesing, anything top-wise is dividing, and then you take your finger and you cover the thing you're looking for, and whatever you're told to do, you do. So I'm asked for distance, I cover distance, and all I can see left is speed times time. So distance equals speed times time. That's what I shall use, distance equals speed times time. So that's divide by time. No. Now again, multiple choice questions, good exam technique. Delete out, eliminate all the things you think you could be, eliminate the things you think are wrong just to check. This is what you should be doing at the end of the exam when you've got time left over. Go through, you're sure that's the right answer, okay? But we all make mistakes. I make mistakes all the time. So I will eliminate my wrong answers. I can see the right answer. I can see it's got to be this one, but I don't want to put a tick in the box yet. I want to just check. Distance equals speed minus time. That's definitely not right. This one, plus time. No, that's definitely not right. So I'm going to go with this answer, okay? Next part, C. During a different part of the journey, the car accelerates from 9 meters per second to 18 meters per second in 6 seconds. I could write out SUVAT and look at what I've got. I don't have that, that's missing. What's the initial velocity? It starts at 9 and goes to 18. So the initial velocity would be 9 meters per second. Final velocity? 18 meters per second. Acceleration? Don't know. Time? 6 seconds. Okay? So, got quite a few of the values. I can't be using this equation for it. And there's a massive clue as to why I don't need to use that equation, because they give me one. So let's just take their equation and try using it. The change in velocity. Well, it went from 9 to 18. So the change is going to be 18 minus 9. That's the change in velocity, or delta V. And then divide by the time taken, it was 6 seconds. So 18 minus 9 is 9. And 9 divided by 6 is 1.5. So 1.5. Don't even need to remember the units, they give you them, 1.5 meters per second squared. Which equation links acceleration, mass, and resultant force? Well, we've already talked about one of the laws, so it's one of the other laws. Which one? It's either 2 or 3. Can you guess? It's 2. F equals ma. Right? Want to see the cheesy t-shirt with the physics guy? May the force be with you, but it doesn't say may the force be with you, it just says may the m times a be with you. Star Wars, yeah, okay. Bit cheesy. So F equals m plus a. No, F equals m times a. That looks right, but I'm not going to tick it just yet because I'll check all the rest. Might, no. Divide, no. It's definitely this one, yeah. Right, E. So we haven't even got to use that equation yet. Where does it come up? Well, this is part of the thing. You need to be able to discriminate and distinguish when to use the right formulas. Don't just shove a formula in anywhere. So the mass of a car is 1,200 kilograms. The driver is 1,120 kilograms. The driver is 80 kilograms. We've got two masses given to us. I wonder why they've given us two masses. Calculate the resultant force acting on the car and the driver whilst accelerating. Resultant force. Oh, hold on. I've just been given this equation. This is what the exam board do. They try to help you a bit sometimes. So they're asking for the resultant force. I've got two masses, remember, and I'm trying to find acceleration. Okay, so let me just write the equation. F equals ma. Right, again, if you struggle with rearranging equations, you need to put this into an equation triangle. So there's nothing dividing, so what do I put on top? Well, don't worry. Just put in the stuff you can see. M times A, that's the timesing bit, and I know the timesing bit in this equation triangle goes on the bottom. Put the F in the top. What am I being asked for? Resultant force. Oh, it's already rearranged. It's already F as the subject of the equation, so I don't need to worry. Right, sub numbers in. The mass. So, in the previous bit of the question, I got the acceleration was 1.5. So I actually have got the acceleration and the mass, that's the entire mass, all the stuff being accelerated. So I'm going to have to add these two things together. So 1,120 plus 80 is 1200 times by 1.5, which is the acceleration, should give me... Bring your own calculators, guys. It's no good. You don't bring a calculator, you're setting yourself up to fail. You'll pick up someone else's, you'll borrow one of the school ones, you won't know how to use it, the settings will be wrong, some kid in year 7's messed with it, you're year 11 and you need to be performing, and some year 7 kid has messed with your calculator. It's not even your calculator, it's the school's calculator. You need your own one. Okay. 1,800 newtons. Again, don't need the units because they've already given them to me, but always check because there's marks available for that. Right, now here we are. This is the bit we've all been waiting for. Can we use the v squared minus u squared equation? It says use the correct equation from your physics sheet. It's one of the rare ones they give you. It does say students should be able to apply this equation which is given on the physics equation sheet. So it's one of the ones they give you. So it says from your physics equation sheet, so that should be prompting you, right, turn to the equation sheet, have a look. So you'll look and you probably don't remember the equation, or maybe you do. Maybe you love this stuff and you do remember it, but maybe you don't. No problem, write it down. V squared minus u squared equals 2as. I'm lost. What have I got? I don't have any information. Why have I just worked out force? What I'll do is I'll collate all my terms. S, U, V, A, T. What do I know? Calculate the distance travelled. So it's asking me to find S. Okay, well I need the initial velocity. I'm sure I saw that earlier. Yes, I was given the initial velocity there. It was 9 meters per second. I've also got the final velocity, 18 meters per second, so I can stick those in. 9 meters per second. 18 meters per second. Acceleration. I worked that out as well, didn't I? There it is 1.5, and I worked it out here, it's 1.5. So they're expecting you to continue using things you've worked out in previous bits of the question. T, we don't have. Also missing. Right. What's it asking me for? S. Okay. So again, I'm going to do it the way I've said to do it in this video to try and make things easier. Let's just go with sub the numbers in. V squared. V is 18. So 18 squared minus u, which is 9, and square it, should be equal to 2 times 1.5 times S, the thing I need to get. Alright, let's do 18 squared. 18 times 18, 324, 324, minus 9 squared, 9 squared, 81, equals 2 times 1.5 is 3, lots of S. Running out of space, I'm going to go over to here. Okay, 324 minus 81, 324 minus 81 is 243. 243 will be equal to 3s. So this looks quite easy to rearrange. 243 divided by 3 will equal s. Yes, £243 to buy 3 lots of s. So I divide by that, divide by 3, gets me a displacement s of 81 meters. So that would be my final answer, 81. Again, they give you the units, so you didn't need to worry about units, but you should always be checking your units because you get marks for it. Final bit. Car driver sees a fallen tree lying across the road ahead and makes an emergency stop. The braking distance of the car depends on the speed of the car. That's true. For the same braking force, explain what happens to the braking distance if the speed doubles, and you should refer to kinetic energy in your answer. Well, you're not given the equation for kinetic energy. I'm pretty sure it's not on your equation sheet, so it's one of those ones you'll have to remember. Not sure about it? You can check my video on it, but I do know that it's half mv squared. That's the kinetic energy. So I'm not going to write out a full answer for this one. I'll show the mark scheme at the end, but if your velocity, let's just say, was 1 and you doubled it to 2, Since the velocity in this term is squared, doubling the velocity does not double the kinetic energy. In fact, it will quadruple it, because if you go from a velocity of 1 squared, so 1 squared, so let's just have a look at this. If this is the velocity squared is 1, no problem. But doubling it gets you 2 squared, which is 4. In fact, tripling it, if you triple it, you don't triple the kinetic energy, what do you do to it? Well, what's 3 times 3 is 9. So the kinetic energy is going to increase with the square of the velocity. So if you double the velocity of the object, you double the kinetic energy, right? You don't double the kinetic energy, you quadruple the kinetic energy, because if the velocity goes from 1 to 2, for instance, the kinetic energy goes from 1 to 4. Okay? Therefore, there'll be 4 times more work needed to be done to decelerate the car. 4 times more work done by the brakes, converting kinetic energy into thermal energy. Okay? So that's what you'd need to be saying for this. And if you're not sure about that last question, that's a nice point to end it on. You need to do some research on energy, and if you want to ask some questions about that, I can do another video on that. This at 30 minutes I think is long enough. Okay, let's just have one last little check of the mark scheme and see if we've got that right. So again, this is how I would be revising myself. So it will have constant speed, yes. Speed times time, yes. 1.5, yes, I got that. 1,800 newtons. Did I get that for my answer? I think I did. Yes, I did. Displacement, 81 meters. Brilliant. Right, let's have a look at the if I get the marks for the written answer. Doubling speed increases kinetic energy. Kinetic energy increases by a factor of 4 because it's been doubled, and because there's a square in there. Work done by brake to stop car increases. Work done increases by a factor of 4. I think I had a good mark for that. Okay, I hope you found this video useful and helpful. Thanks for watching. Comment, like, subscribe and share.